The discovery of the James Webb Space Telescope, JWST, has shaken the foundations of our cosmic understanding, challenging established rules and revealing hidden mysteries of the cosmos. This unprecedented breakthrough has generated palpable anticipation in the scientific community, as each observation provides new insights into the universe and its deepest secrets. The massive object recently detected by the JWST raises questions about the origin of the universe, and its identity remains a fascinating enigma. This discovery revolutionizes our perception of the cosmos and invites us to explore new horizons of understanding. Join us as the James Webb Space Telescope takes us on a journey through time, revealing cosmic secrets that defy our imagination. On December 25, 2021, humanity took a leap forward in space exploration with the launch of the James Webb Space Telescope, JWST. This cutting-edge instrument in cosmology and infrared astronomy has opened up new possibilities for studying distant stars and galaxies, providing exceptional resolution and sensitivity. One of the JWST's most outstanding achievements is its ability to observe the cosmic past, allowing us to study the first stars and galaxies, as well as to accurately analyze the atmospheres of exoplanets and the enigmas of black holes. These cosmic phenomena, formed by the gravitational collapse of stars, represent areas where the laws of space and time are extremely distorted, challenging our fundamental understanding of the universe. The event horizon, known as the point of no return, is a region that challenges the fundamental principles of modern physics. Although black holes are relatively recent discoveries, the theory of relativity had suggested their existence long before they were directly observed. This theory postulates that sufficiently dense masses can bend spacetime, giving rise to strange structures that we call black holes. The reality of black holes, initially invisible, becomes evident thanks to their gravitational effect on the surrounding environment, including space satellites and nearby materials. Scientists use a variety of sophisticated instruments to detect evidence of black holes. They observe how nearby stars and their surrounding gas are affected, analyzing gravitational effects to determine whether they are orbiting a black hole or being ejected by its immense gravitational pull. The James Webb Space Telescope, equipped with advanced tools, allows us to probe deeper into the universe and tackle problems once thought to be undetectable, such as the nature of black holes and nearby stars. When objects approach a black hole, they radiate large amounts of energy, illuminating the galactic scene. However, despite their dramatic impact on their surroundings, black holes remain enigmatic, especially in terms of their dimensions, as their precise size remains undefined. This is because the gravity of the black hole determines the fate of any object that comes too close. The no-hair theorem further explains this mystery, suggesting that once a black hole reaches stability after its formation, it has only three measurable properties: mass, electric charge, and angular momentum. However, this apparent simplicity masks the inherent complexity of these cosmic phenomena, making it difficult to distinguish between black holes that may have similar physical characteristics. Examining the types of black holes reveals a diverse family with distinctive characteristics. The first type, the stellar black hole, is the smallest, with a mass between 1 and 100 times that of the Sun. On the other hand, there are supermassive black holes, which can weigh millions or billions of times the mass of the Sun. It is believed that the death of massive stars in the early universe gave rise to these supermassive black holes. In the middle range, there are intermediate black holes, which lie between stellar and supermassive black holes. Contrary to popular belief, some black holes can be relatively small, reaching the size of an atom. It is difficult to imagine that such massive stars could collapse to such a tiny size while maintaining such a gigantic mass. However, the reality is that the Milky Way, and the universe in general, contains a multitude of scattered black holes, each with a mass equivalent to millions of times that of the Sun. Theoretical and empirical observations have shown that the largest black holes tend to occupy a central position in galaxies, including our own Milky Way. At the center of the Milky Way resides Sagittarius A*, a supermassive black hole with a colossal mass equivalent to about 4 million suns. This makes it the most massive object in its galactic environment. Ongoing research on black holes raises the question, what makes them so fascinating? The inherent complexity of these entities has kept scientists busy for decades. Black holes are truly cosmic laboratories that challenge numerous theories rooted in general relativity and quantum mechanics. They also offer opportunities to explore unknown areas of physics, expanding our understanding of the fundamental principles of the universe. However, our understanding of black holes remains limited because we cannot observe them directly. Stellar mass black holes, for example, reach temperatures in the billions of Kelvin, which limits us to using indirect methods and theories to study them. At the heart of the intrigue surrounding black holes is the event horizon, a boundary in spacetime from which light cannot escape. This fundamental feature not only denotes the gravitational power of black holes but also represents a domain of reality beyond human comprehension. As we approach the event horizon, the laws of physics undergo profound changes, but they still offer a window into the mysteries of these phenomena. While we understand how some black holes form as a result of the gravitational collapse of massive stars, the exact process remains a subject of study. Scientists point to the importance of high-density environments, such as those within stars, for this type of collapse. In today's universe, however, during the early stages of the universe, the extreme densities of the Big Bang significantly increased the probability of black hole formation. In addition to high densities, black hole formation requires an uneven mass distribution to prevent matter from becoming uniform in such dense environments. It is believed that initial fluctuations in density allowed black holes to grow through gravity. Gravitational collapse is not the only way black holes can form. High-energy collisions can also create them if the density reaches sufficiently high levels. However, since 2002, no such event has been detected, either directly or indirectly, although hints of mass imbalances have been suggested in particle accelerator experiments. What is fascinating about black holes goes beyond their formation. Their dynamic nature is equally intriguing. They have no defined size and can continue to grow without limit by absorbing surrounding matter, such as gas and dust. This process is responsible for the creation of supermassive black holes and is thought to be a pathway for the formation of intermediate black holes in globular clusters. Black holes can also merge with other objects, such as stars or other black holes, to form even more gigantic black holes. Despite these complexities, black hole formation remains a subject of study, and with the operation of the James Webb Space Telescope, we are poised to discover more details. However, concerns have arisen about the possibility of a black hole impacting Earth and destroying it. Scientists, however, have ruled out this possibility, demonstrating that a black hole of the same mass as Earth would not suck it in, but would instead orbit around it due to its equivalent gravitational attraction. Additionally, black holes do not roam space consuming celestial bodies. The Earth is far from any dangerous black hole, making such a scenario highly unlikely. If you enjoyed this information, leave a like, share it to reach more people, subscribe, and activate the notification bell. Thank you for watching, and I'll see you in the next video.